Hi, 4th and 5th graders. We're back today, Thursday, to share with you our Clue 4 and Clue 5. So here we go. There are 4 digits that cannot be seen in this picture. Those 4 digits are not in the answer. So if you look over here, what digits can we see in these numbers?
32, 58.
No, just the digits.
3, 2, 5, 8, 1, 7.
Okay, so the ones that cannot be seen are not in the answer. So we can see a 1, a 2, a 3, a 5, a 7, and 8. So which digits can we not see?
You cannot see 4, 6, 9, and 0.
So 4, 6, 9, or 0 cannot be in your answer. You had changed it to what? 80?
73.
Or 73? Okay, so you're okay with 73?
Uh-huh.
All right, think about your answers, boys and girls. Are you still good to go? The answer is not a multiple of 3. Is 73 a multiple of 3? Think about your number. Is your number a multiple of 3? If you count by 3s, 3, 6, 9, will you eventually get to your number?
3, 6, 9, 12, 15, 18.
As Patrick's kind of thinking through his multiples here.
27, 30, 33, 36, 39, 40, 42, 45, 48, 51, 54, 57, 60, 63, 66, 69, 72. Okay, I'm good.
You're good? All right, Patrick's sticking with 73. Think about your answer as well. And we will go ahead and reveal. Drum roll. Ah, 73. All right, so again, think about your estimate that you came up with first. Were you pretty close? What was your first estimate? Do you remember?
It was 10 away.
10 away. So that's a pretty good estimate, right? Started at 63, had to adjust until he got to 73. Hope you guys have a great day. Bye.
Let's say that this rectangle, this green rectangle right over here, let's say it had an area of 268 square units, whatever those units are. You could imagine them being square centimeters, or if you imagine this being a big field that you're looking at from space, it could be square miles or something. So I'm just going to write square units. And let's say you knew the dimensions of one side of the field. So let's say that you knew that this, let me just color, let's see, let's say you knew that this side of the field right over here, the length of this side of the field is 2 units. 2 units. And I haven't really drawn this to scale. If I wanted to draw it to scale, it would be like much shorter. It would be like that, but you would have trouble seeing the rectangle then. But let's just assume it's 2 units. So if you know the whole area is 268 square units, and one side is 2 units, what's the other side going to be? What is the other side going to be? What is, let me pick another color. What is this side? What is this side of this rectangle, this field, whatever this might be? What is the length of that side? Well, if you multiply these two sides, you get the area. So if you start with the area, if you start with 268, and you divide by the other side, you're going to get the length of this side right over here. So if we wanted to figure out the length of that side, it would be 268 divided by 2. And you've already seen, or we've already seen, multiple ways to figure out what 268 divided by 2 is. But the whole reason of me drawing this rectangle or this aerial view of this field or whatever you want to call it is so that we visualize it using area. And so one way to do it is to break up this 268 square unit area into areas that are easier to imagine dividing by 2. So here I have the same field, but I've just broken it up. So it's the same field. This dimension right over here is still 2 units, but I've broken it up. This blue area is 200. Let me do that in another color. So this blue area is 200 units. This yellow area is 60 units, and this magenta area is 8 units. Now, why is that useful? Well, now each of these, it's much easier to divide by 2. All I did is I took the 268 and I said, well, look, this is the same thing as 200 plus 60 plus 60 plus 8. I just broke up the 268 into things that are easier to divide by 2, and now I could take those things and divide by 2. I could take each of them and divide by 2. So what is this dimension going to be right over here? Actually, let me do that in a different color. What is this dimension right over here going to be? Well, 2 times that is going to be 100. So this is going to be 100. And how did we get that? Well, we got that by 200 divided by 2. 200 divided by 2 is 100. What's 60 divided by 2? Well, 60 divided by 2 is going to be 30. So this part of the field is going to be 30 in that direction and 2 in this direction. And once again, not drawn to scale. And then finally, what's this section going to be? It's going to be 8 divided by 2, which is 4. Notice, 100 times 2 is 200. 30 times 2 is 60. 4 times 2 is 8. And so this whole length up here is going to be 100 plus 30 plus 4, or 134. And we've already seen other ways of coming up with this. You can say, look, 2 hundreds divided by 2 is 100. 6 tens divided by 2 is 3 tens. 8 ones divided by 2 is 4 ones. And that's exactly what we just did over here, but we visualized it using this kind of a rectangle, breaking it up into chunks that are maybe easier to imagine dividing by 2. We broke it up into 2 hundreds right over here. We broke it up into 6 tens, or 60, right over here. And we broke it up into 8 ones. 8 ones. We broke up the area, and then we took each of those areas and we divided it by 2 to find that part of the length. And when you add them all together, you get the entire length. Now, that's just one way to do it, where you take each of the place values and you break up your field or your rectangle like that. But you could do it other ways. You don't always have to break it up that much. For example, let's say that this area is 856 square units. And let's say that this dimension right over here is 8 units. So how could we break this up so it's easier to think about what the other dimension will be, what the length is going to be? And this length, once again, is going to be 856 divided by 8. 856 divided by 8 is this length right over here. Well, you could break it up into 8 hundreds, 5 tens, and 6 ones, but you might notice, well, 5 tens, it's not so easy to divide that by 8. But we can divide 56 by 8. We know that 8 times 7 is 56. So what you could do is you could break this rectangle into the 856 square units. You could break it up into 800 square units, and then another 56, and another 56 square units. So once again, we broke it up into 800s, and then 56 ones, and then 856 ones. Same area, I just broke it up. And now if you say, look, this is 8, if you say this right over here is 8, well, what is going to be this length? What is this length up here going to be? Well, it's going to be 800 divided by 8. So actually, let me write it below it. So 800 divided by 8, this length right over here is going to be 100. How did I get that? I got 8 hundredths divided by 8 is 100. 800 divided by 8 is 100. And then you have this other magenta part. What is 56 divided by 8? Well, that's 7. 56 divided by 8, this length right over here is going to be 7. So what's this entire length? Well, it's going to be 100 plus 7, which is equal to 107. So once again, you could have said, look, 8 goes into 800 100 times, 8 goes into 56 7 times, 107. Why did Sal draw these rectangles? Well, just so that you can help. It's sometimes helpful to visualize this. Is, hey, look, this is an area problem. If this is the total area, if 856 is the total area, and 8 is one of the dimensions, well, then 856 divided by 8 is going to be the other dimension. And one way, when you're breaking this up by place value, you're breaking up the numbers into pieces that are easier to divide by 8, you could think of it as you're just breaking up that area and you're just trying to figure out parts of this length. So that's 100 right over there, and then this right over here is 7. So anyway, hopefully this broadens your visualization capabilities when you are dividing multiple, when you're doing division.